Hello everyone, here it's Yuanhui, and in here I'm gonna go over the question 1 in homework 3. So in question 1 it says let probability x equal to k equal to b times k times p power of k multiplies 1 and k equal to 1, 2, 3, stuff like that until infinity, and p larger than 0, smaller than 1. So let's see the question A. It's asking us to finding b so that probability x equal to k represent a probability mass function. So let's see my working process. In here we list out the function of the question given, and as a question function above, we can get a function like b equal to such like that, sigma k to infinity and k times p power of k minus 1 over by 1. And in the next line here, from the question, we can get sigma k equal to 0 and to infinity, and p power of k equal to 1 plus p plus p power of 2 and plus p power of k. And from that, we can get a function like 1 over the 1 minus p. So by put the b equal to this one, by taking this question into this one, so finally we can get like this is like a derivative of the above one. So after that we can get the result like this. And since we already got that, we can take this into a question we calculate out in the previous step. So in that, the b is equal to 1 over 1 minus p power by 2, and the result is 1 minus p power by 2. And in question B, it's asking finding the EX. So let's see here. According to sigma k equal to 0 to infinity, k times p, and times the probability x equal to k. So we can get that such like the perverse one, but the k is power of 2. And by taking what we already got in the part 1, put this into the function, and we can get this. And in the next step, we take this one in front of the sigma, and that's the result. That's a part of result we got until now. And according to the A, like here, this one equal to 1 over 1 minus p power of 2. So in the next one, we times p for both sides. And you can see here the minus 1 was being covered. And we take derivative. So we can get a list like this. The result is 1 plus p over 1 minus p power by 3. According to this step, we got the EX is already easily can be calculated out. So by times them together, and finally we got EX power of 2, it's like 1 plus p over 1 minus p. So that's the result for question number 2. And for question number 3, it's question number C, sorry. It's asking us to get the EX power of 2. So since we already got the step from the part B, so it's easily quick take it in and calculate out. Like in here, k equal to 0 to infinity of the sigma, and k power of 2 times probability x equal to k, and calculate out the result at infinity of sigma and k equal to 1, and k power of 3 1 minus p power of 2, and probability power of k minus 1. And we take the previous step in the function and adding them together, we can get our result out. Like the step in problem B, times them together, and finally we got the result is 1 plus 4p plus probability power of 2 over 1 minus p power of 2. That's the result for question C. And in question number D, it's asking us to calculate out EX power minus E power of 2x. So let's see. Let's see the part D. Since we already got the EX power of 2 and E times E powers 2x, it's like the power of EX. What we got are in the part B, so we just take them in the function, and usually to calculate our result is 2 probability over 1 minus probability power by 2. And in question number E, it's asking let probability equal to 1/3. Find the conditional probability mass function probability x equal to k, or x larger or equal to 2 and smaller or equal to 5. Let's see how to count my steps. So as p equal to 1/3, b equal to 1 minus probability power of 2, and we can take this in to calculate out b is equal to 4 over 9. So the probability for x equal to k, or x larger or equal to 2 and smaller or equal to 5, it's equal to we take this over and over the sigma k equal to 2 and to infinity, and times probability x to k. And after that, we can get probability x equal to k with x larger and equal to 2 and smaller and equal to 5 over sigma k equal to 5 to 2 and times 4 over 9 times k 1/3 power of k minus 1. So we can calculate out, take those data of number in. It's like 1 over 0.538 times 4 over 9 times k times 1/3 power of k minus 1. And we finally calculate out the result is very close to this number. So according to this result, we can get the conclusion is k equal to 2, 3, 4, 5 or 0 in the otherwise. So that's all the 5 part of question 1. So that's it. I think it's the end.